So I've been given the difficult task to give the first presentation after lunch. So I will try to keep you awake. My name is Lars Bendix. I'm here today, sponsored by the Scandinavian Network of Excellence in Software Configuration Management, which is a group of Scandinavian people who are passionate about software configuration management. And I'm also affiliated with the IT University in Copenhagen, Denmark, and Lund University in Sweden. So what I'm going to talk about today is mostly some of the things that we do know about continuous delivery. And we're doing a research project where we would like to find out what it is that people would like to know, but that we don't know yet. So I have a PhD in configuration management. I've been a lecturer and researcher for 7 years at Aalborg University before I moved to Lund University, where I've been for 16 years now. I worked for 30 plus years in software configuration management, so I feel pretty old now. And for 15 plus years I've been working with and been interested in Agile. Actually, it was some of my students at Aalborg University who introduced me to Agile in the beginning, saying that, "Prof, we got this new exciting thing. It's called Agile. It means that you can do whatever you want to do." I said, "Well, I'm not sure." Yeah, we can do whatever we want to do. So I was curious and I went and I looked up what Agile actually is, and I had to go back to the school and say, sorry, it doesn't mean that you can do what you want. It means that you have to be very, very disciplined and organized, and within that context, you can improvise and adapt. L'arte italiano di arrangiarsi. But if there is no structure, then it becomes a lot more difficult. I'm doing research with industry and doing some networking and a little bit of publicity. So this Scandinavian Network of Excellence in Software Configuration Management has also for some years had an Italian branch. So sometimes once a year I go to Italy, to Parma, to teach a little bit of configuration management to their students at the university there. And I've managed to get together a small group of people from industry interested in software configuration management, and we meet twice a year in Parma. Next time will be May 12th, and then again in late October. And we have a lot of interesting and sometimes slightly heated discussions. Well, you know how Italians are when we get started. You can go to the website and click to the Italian branch if you're interested. I was also here last year, telling some experience from how our students' perception of continuous delivery is and how they do and what they shouldn't do when they try to do continuous delivery. And they sort of have the idea that you get a story or something from the user, and then it is put into delivery, into operations. And how does that happen? Well, we got the code ferry, continuous delivery ferry, vroom, vroom, sprinkle some magic dust, and then it goes into operation. It's not really like that. There's a lot of bullshit around. People will tell you that buy this wonderful mixture and I will guarantee that it'll grow hair on a bald man's head. So, trust me, it doesn't work. So, what I tell my students is that when you tell me something, when you write something for me, I don't want to hear, I believe that you can. I mean, I'm at the Faculty of Engineering. We are doing software engineering more than we're doing computer science, but it's still science, it's engineering. If you want to say, I believe that, then you should go and study theology, because that's where they believe. I think that this can maybe work somehow, then you should go and study philosophy. That's where they think. From this example we can generalize, study social science. I say that we have decided that from tomorrow the water will run upwards. then you should be a politician, because that's what they do in Parliament. I've heard that become a journalist. And sometimes my students, they put in, well, Lars Bendix said, that doesn't work. We are doing real science, and we know, because we can prove, we can demonstrate, we can logically deduce and reason about things. And that's what I would like to bring a little bit into the continuous delivery discussion, the continuous delivery DevOps discussion. So what we are good at academia is to think. So we observe things preferably from real life if we can. Then we reflect and we try to understand. So, well, you know from the Bible that God created everything. Unfortunately, God forgot to give us the master plan. So we don't know what is the reason behind everything and how the structure is. That's what we're trying to find out by observing. We're trying to systemize and categorize, and then we can put our hypotheses, our ideas, our claims. So we test and verify them, and then we take a couple of surveys around this again. What industry is good at is to do, to act. So you produce products, you do measurements, and you produce numbers. And if we join up industry and academia, we can do wonders. So with the models from academia and all the metrics from industry, we can have predictive power. When we have this model, when these numbers are put into the model say that this is going to happen. So now we don't need any priest to tell us when will be the next lunar eclipse, because we got models and we got empirical data for that. Now we're starting up a research project looking into, well, we call it continuous software engineering, because we want to look a little broader than just continuous delivery. Also on what does it do to the organization if the technical guys and the developers are able to actually deploy 30, 40 times a day. I mean, will the product owner manage to keep up with this velocity? So some of the questions that we are looking at is, what is the current state of the practice for continuous software engineering industry? What is it that we know about continuous software engineering? And what are the prerequisites for continuous software actually to work? And some of these things we'll not go through today, but that's some things that we would like to discover also during our research project. So we've been doing a pre-study from literature, and we have also done, 9 interviews with different companies practicing continuous delivery. First, here the results from looking at papers, looking at what people have actually tried to find out about continuous delivery. So Puppet Labs, they do a state of DevOps survey every year. 2015 they had almost 5,000 respondents. They divide companies up into high performing, super high performing, medium performing, and low performing. And the numbers they come up with is that high performing IT organizations, they deploy 50 times more frequently than other organizations. They have 200 times shorter lead times. So if another company can deploy in 200 hours, a high-performing IT organization would be able to do it in 1 hour. They have 60 times fewer failures, and they recover 168 times faster from failure. They claim that these super high-performing organizations, they do this because of DevOps practices. I would say that is, they do a little bit of statistics and they reveal a little bit about what is behind their numbers. But so far I would say that this is more a claim. Probably it's not completely true, but I would sort of say that it's not completely wrong either. So other research sort of confirms some of these numbers. IBM has also written a white paper trying to pick up on their experience with doing consulting in companies and trying to help companies. and trying to find some good practices on how to strengthen the release management. So you should establish a single source of truth. So other people, they call that trunk-based development or whatever. Automate painful tasks. Try to manage the inter and intra-application dependencies. So this is one of the things that are causing problems to a lot of companies, that if we change here, whatever needs to be changed. Or if we build this one, should we also, well, whatever. Make what is where visible, make certifications and approvals visible so everyone can see them and use them and know when something happens. So try to create transparency. Deploy consistently across environments. So you don't deploy in one way in one environment and a different way in another environment. And make the release plan easy to consume. And I would say that one of the things that our students, they violate when they try to take a turn with continuous delivery is the last one. So they have, well, release plans that are crappy and they're not easy to consume. And when they try to automate that, what do you get when you try to automate a crappy process? You arrive at crap much faster. So, well, some Finnish researchers interviewed 15 different companies that with a focus on continuous deployment, and they were interested in finding out what were the perceived benefits, why did they want to do continuous deployment, and what do they see as the obstacles. And benefits that they would like to go for was things like faster feedback, to have more frequent releases, and improved quality and productivity, and improved customer satisfaction. So this is why at least 15 Finnish companies, they would like to go into continuous deployment. The obstacles that they saw was resistance to change. The people that they interviewed here was top management. So the resistance to change, to go in from a traditional way of developing software into continuous deployment, didn't come from top management. It came from the developers. That's not the way we're used to working here. We don't like changes. We prefer to work as we've always done. Customer preferences. So, well, at the keynote, there was a question about, well, if you deploy 30 to 40 times per day, now how does your help desk keep up with this moving target? So when a customer calls in and says, I got a problem, usually the first thing you ask the customer is, what version are you on? But I mean, if you create 30, 40 new versions per day, I mean, it's, well, domain constraints. Some of the companies were having constraints with the problem domain. Developer trust and confidence. Again, the developers are reluctant to actually believe that this can work. And they were having some legacy code considerations based on this. There is not very many numbers around when you go and ask companies. When you go and do research in a company, you have to sign a non-disclosure agreement, and many companies, they are not very happy for releasing numbers. So a lot of the numerical empirical research has been done on open source projects where you have open access to all their data. Mozilla at a certain point changed their way of development from having central repository and automated testing after the commits to having an integration repository, having sheriffs that checked the submission, and if it was good, it went to the central repository. If it wasn't good, it was sort of ditched. And then they looked at the numbers, saying, well, the early backout rate, backing out of patch very early in the development was 3.5%, and backing out late, that is towards the release date, was 1.5%. Before you introduced the system, after you introduced this system, they backed out of 8.3% before very early, and very late in the development was only 1.5%. So they actually got a higher quality from introducing this system. At a certain point, Mozilla went from an 18-month release cycle to a 6-week release cycle, and some people were worried what would be the effect of having a much shorter period of doing testing. So before we had 18 months to do testing, now we have 6 weeks. So what was the effect on quality? Well, there was no significant increase in post-release bugs. So we get the same quality. Or maybe even better, no significant increase in the daily crash count. I don't quite understand this because my Firefox has a significantly higher uptime before it crashes than 10 minutes. So, well, that's the number that they bring. Effect on fixing bugs, the number of bugs that were fixed went down, but the bugs that got fixed were fixed much faster. And then they also ask themselves, do users actually pick up these deliveries when we go into a faster release cycle? And yeah, they actually do. So before, it took 7 to 9 weeks to get a 50% coverage of the new release. After they went to the 6 weeks, it took 3 to 8 weeks to get 50% adoption. So users out there, they sort of tend to pick up on the latest and greatest. Another couple of researchers, a joint project between the US and China. So this must have been before Trump became president in the US. And they looked at projects that were hosted on GitHub. And what they wanted to investigate was, is there any difference in before we do continuous integration and after we do continuous integration? So they filtered out all the projects that had been doing some time of the development without continuous integration and some part of the development with continuous integration. Then they also filtered out all the projects that had been using Jenkins, because Jenkins was sort of outside of GitHub, so they couldn't pick up data from that. So they used the CI Travis. And they got 246 projects that they could study. They do, in this paper, a lot of heavy statistics, because there's such a variance on the numbers that they get out. And there are so many factors that can actually influence this, apart from the fact that they had continuous integration or not continuous integration. But they find that for most of the results, then the statistically significant factor for this is the continuous integration, not the number of code lines or whatever. So were the productivity affected, as understood as the number of pull requests that were merged per month? So significantly more effective in merging core pull requests. So from the core developers, we got more efficient in merging their pull requests. For the external pull requests, there were a significantly lower rejection rate, meaning that we got a higher quality from the external people. And as one of the people in the project commented, then, well, when we got a continuous integration framework, you should be a fool if you didn't test your patch against that before you send it to the integrator. What is the effect on the quality? So the core developers find significantly more bugs, and the users, they do not experience any increase in bugs. So bugs are more easily found before they get out there in the open. A web-based financial system, a case study, and what factors impact the rapid release, time that it takes from something is coded until it goes into production. And they found 3 overall groups: technical, organizational, and interactional things. For the technical thing, the merge and integration, merge and stabilization. So it took about 6% of the time for the technical things to merge stuff from other people. So they were having a dedicated integration and release team that took things from the different teams and merged and integrated that. Testing was 86% of the time. They had quite a lot of manual testing when they were doing these things. Also things like functional dependencies, release planning. So we cannot release this functionality because it is sort of related to this functionality. So either we don't release any of these or we have to release both of them. So there were some release planning and trying to figure out these functional dependencies. Also, design of an appropriate branching structure was important and an impacting factor on the rapid releases. And for the interactions, the coordination between the different groups, and what they call socio-technical congruence, which basically means that you have to exercise your social skills or show that you actually have them. Another study, doing some literature study to try to figure out what is important in the domain of continuous delivery, doing qualitative interviews with 20 different companies in Germany and Switzerland, and doing some quantitative survey where they got 178 replies. They sort of said, well, when a company transforms from a traditional company gradually into a smooth working continuous deployment, or whatever you want to call it, company, you go through 5 steps. This stairway to heaven, or actually the way that I've drawn it, it looks a little bit more like a stairway to hell because it's going down, but it's actually meant to be a stairway to heaven. It's inspired by work of Jan Bosch from Chalmers University in Sweden that also has some. So you are a traditional development organization, you transform into agile, and being agile you can pick up on continuous integration. The next step you do is continuous deployment, and finally when you arrive in heaven you can do partial rollouts and all the interesting things. If we look a little bit more in detail, they say that continuous integration, 3 important points to be in continuous integration is trunk-based development, feature toggles, and full developer awareness. When they actually asked the companies, and in the survey, it turned out that trunk-based development was not very used, and feature toggles were not used that much, which makes you wonder why they put it under continuous integration and not one of the final things that you should do. I would say that trunk-based development is one of the first things that you should try to approach. Feature toggles, we saw the keynote this morning that there are some ways that you can do feature toggles, but the experience with feature toggles is that it can become rather complex. So I would rather put that also in partial rollout because it's something that's related to canary releases and A/B testing. Continuous deployment is when you do health checks, you have developer on call, and you have a deployment pipeline. So health check, well, any sane company should get some customer feedback and take that into consideration. But when you want to do continuous deployment, you also have monitoring. So even if your customers don't complain about things, then you monitor the things and you discover before your customers that something is wrong and you can fix it. Maybe before the customers, they know it. Developer on call, which means that for at least a couple of hours after something has been deployed, 30 times a day, for a couple of hours you're on call. So if something happens, then you can fix it. If it doesn't happen within a couple of hours, 3-4 hours, then you can do something else, and then you're up. A lot of companies, they actually use that. The development pipeline, it turned out that 70% of the companies, they used the same deployment pipeline for hot fixes as they used for normal features. Of the 30% that had different deployment pipeline, 20% answered that it was completely separate, so it was completely different from the way that they developed features. About 50% that they were doing only a subset of the test, and about 50% that had reduced the number of steps and phases in the deployment pipeline. It was a multiple choice, so that's why it doesn't sum up to 100%. Canary releases and A/B testing apparently not very used by the sample that they have, and the main blockers, architecture, and for the A/B testing, that if you don't have a huge number of customers, then A/B testing is not statistically significant. One of the developers commented that we've got so few customers, it's actually easier to talk to them than to try to do A/B testing. From the trenches, Paddy Power, an Irish betting company, they have around 400 developers. They have teams of 2 to 26 people, mainly 4 to 8. Before they went into continuous delivery, they had less than 6 releases per year on average for the applications. They were doing extensive testing and bug fixing towards the end. It artificially delayed features that were ready early but had to wait for the release date. It was an error-prone manual release process. People had little practice with the release process because they did it so rarely, and setting up a test environment could take up to 3 weeks. They did a continuous delivery transformation. They had a dedicated team of 8 people. They have been working for more than 2 years on this, and what they arrived at was that each application has its own continuous delivery pipeline. Pipelines, they differ slightly. They are triggered after each commit, and they went from doing phase builds. So for each phase, they were doing a new build for some reason, into we do one build, and that build goes through all the phases. And they went from physical machines, where you have to ask for a machine and you have to wait for 2 or 3 weeks until it gets delivered, to pushing a button and you spin up a virtual machine. The results, without giving any numbers, was that it improved the productivity and efficiency. They obtain user feedback more quickly, they get more reliable releases, and they improve the product quality. Actually, one of the results was that they ditched the bug tracking system, because they say we get bugs so rarely that we don't need the bug tracking system. When we get a bug, we take care of it immediately, and then we don't need the bug tracking system. The biggest challenge that they encountered was organizational and some of the processes. Riley Software went from Agile, Scrum, 8-week sprints, which meant 7 weeks of programming and 1 week of hardening the code so it could actually be released, to a Kanban approach where they did some continuous delivery, and the purpose was that they would be able to release at will. The benefits: greater control and flexibility over feature releases, so they didn't have a fixed release schedule. So when they wanted to release something, they could release it. So if my feature is not ready today, where the release was scheduled, well, we can release it tomorrow, or Monday, or whenever. They could incrementally deliver value. It was easier to onboard new developers when they had this set up in the framework. And there was a considerable uptick in confidence when they were doing a release. The risks were associated with the build systems and some of the technicalities around that, the automated test suites, and the internal communication. Results, we've seen it before: increased productivity, fewer defects, and lower risk. So they actually have a graph where they track the bugs that they have. They still have a bug tracking system here. And you can see that the band between the tops, it goes a little bit like this, and then, oh, that was the release, and then it sort of stabilizes. But the band narrows, so it becomes more predictable. Like it was said this morning, we always make mistakes. We cannot get rid of that. But if we can make it sort of predictable, and that was what they could. Well, I think I can skip this one. So I want to introduce you to 2 famous people from the configuration management world. This is Stuart Feldman, and he is the inventor, the father of automation. So his problem was that it took too long time to type manually when you had to build systems and try to test them. And he didn't need to build everything all the time, and it was error prone to type these things in manually. So he invented Make. And today that is called Jenkins or whatever. So it's slightly more sophisticated today. The result is that you type one line or you push a button, and then a lot of the magic, the code there. You get optimized builds. It's much easier to get feedback, and therefore you ask for feedback much earlier. And you don't get any typos. So I've heard that the Amazon cloud system had a problem last week or 2 weeks ago because a system administrator had to close down some servers, and he made a typo, which meant that a lot more servers were closed down than he anticipated. Like 5 or 6 years ago, the Swedish domain came off the internet because there was a dot too much in something that was typed in manually. But I don't need to test this. It's so easy to write. It's just one line, and you put a dot too much, and well. The Software Configuration Management Hall of Fame, the first person I introduced there is Wayne Babbage. So back, and well, Make was invented in the early 70s. So there's basically nothing new in continuous delivery. Wayne Babbage wrote his book in '86, more than 30 years ago. Shared data. When we were talking about these dependencies between different things, go and look up what Wayne Babbage means about shared data. The double maintenance, well, if you have tried to merge things, then you will know what double maintenance is. 2 people, 2 teams, or whatever, 3 teams, 4 teams, touching the same code in parallel. And we got double maintenance, and we get a lot of problems. And in his book, he also mentions that an ounce of derivation is worth a pound of analysis, which means a little bit of diff is worth a lot of analysis. If you can say it works, doesn't work now, it worked yesterday, what's the difference between today and yesterday? Well, we put in 52 new commits. Good luck. But if you have just one commit between when it didn't work and it works, then the problem is much easier to find and fix. So, what did you learn today? Well, you're just like my students. When I ask them questions, they're just like fish. So, what is it that we actually know about continuous delivery? Well, a number of facts. Fact number 0 is that it's all about feedback. Fast feedback. That is why we're doing continuous delivery. And never ever forget that. We do it because we want feedback. Developers want feedback, is my code right? The management wants to have feedback from the customers. Are we doing the right features? Do they like this? Is there a higher click-through when we do like this instead of when we did like that? The delivery frequency, I mean, Firefox is doing 6-week releases. They think that that is frequent releases and fast releasing. Facebook, they do like, well, we heard this morning, 30, 40, 50 deploys per hour, just like Amazon. But there's a whole range between the Facebook way and the Firefox way. And you can still get a lot of benefits from continuous delivery. Customer experience quality does not suffer, and developer productivity does not go down. And you need to balance between speed and accuracy in your continuous delivery pipeline. So if I want to have a continuous delivery pipeline that will actually deploy, earlier this week I talked to a former student of mine who works in sort of a big pension bank in Denmark, and he said, well, some of our test cases take 2 weeks to run. Yeah, a developer cannot wait 2 weeks to get feedback. So you need to be able to have a slider to say, well, there are some tests that we don't do. There are some steps that we don't do. And we can give you feedback in like 5 to 10 minutes. It's not 100% accurate, but it's blistering fast. And then when I go to lunch, an hour and a quarter here, then I put the slider to lunchtime, and it can do a little bit more. When I go home at 5 o'clock in the afternoon, I put it to, well, during the night you can do something. And when we finally want to deploy this, then we do the full Monty. So these are some of the things that we should do. And finally, never ever trust that hair can grow on a bald man's head, no matter what they tell you. Thank you very much for listening.